All right, let's go ahead and take a look at another speed word problem. We're going to be looking to see what we did the other times too. Not rely on formulas or memorization, but instead use what we already know, what's given to us to solve this word problem. Our problem is going to be a cyclist travels at a constant speed of 12 miles per hour. How long will it take to travel 9 miles? So again, we'll ask ourselves, what do we know and what are we solving for? So the numbers in the problem are our first clue. We're given that the cyclist is traveling at a constant speed. So we know that the speed is equal to 12 miles per hour. And you know that I do like to keep my units in here. It makes it easier when we do want to use any kind of formulas to make sure we're plugging in the right thing. And then the other number we have in our problem is 9 miles. So miles has a unit of, it's a distance units. So the 9 miles refers to the distance. And then the question itself, how long will it take, tells us that what we're looking for is the time. How long is going to be looking for a time. So the answer, how long, we need to know the time. All right, so you might be tempted to just jump straight into using a formula, speed, distance, time. There are the three formulas, all based off speed equals distance over time. But we're not going to go ahead and do that. Instead, we're going to use what we know and what we know about numbers, the operations, to solve this problem. So our speed is 12 miles per hour. And what does that mean? That means that for every distance, we're going to go it's going to take a certain amount of time. So I'm going to set that up as a simple ratio. You could, of course, spell out distance and time, but we're just going to keep this nice and simple. Our distance is 12 miles, and our time is 1 hour. If I'm looking at this, I can see that what I really want to solve for is 9 miles. Now remember, when it comes to ratios, we can't just subtract some numbers from both sides. Even though 12 minus 3 would give us 9, 1 hour minus 3 hours would give us -2 hours, which doesn't make any sense in this context. So when you are manipulating lines in a ratio, you do have to make sure that you're either multiplying or dividing both sides by the same factors, or if you are using addition or subtraction, that you are keeping in mind that the units need to match to adding or subtracting the same type of thing from both sides. So if we were going to subtract 3 miles on this side, we would need to know what the equivalent time component would be that is related to those 3 miles. But I am looking at this and I see 12 and 9. You would be able to change 12 miles into 4 miles. I'm going to just give ourselves a little bit more space here. I would change it into 4 miles with a simple division, and this would be 1/3 of an hour. Now, that's great, but we now know that this actually isn't going to be that helpful, because remember, we're trying to get to a distance of 9 miles. Now that we're at 4, we're not going to easily get to our 9 miles. So instead, this is not wrong, it's just not helpful in this case. So we're instead going to go to 3 miles. Instead of dividing 12 by 3, we're going to divide 12 by 4, so the other side of that. And then we have 1 hour divided by 4 as well, so that 3 miles is equivalent to, or it'll take a 1/4 hour to travel 3 miles. Now, if you wanted to, you could absolutely change that into minutes. In fact, we could have changed it 1 hour to 60 minutes up here. And then we have 15 minutes right here since it's a quarter of an hour. Now we're in a much better position. If we want to get from 3 miles to 9 miles, that's going to be 3 sets of 3 miles, or 3 sets of 1/4 of an hour, 3 sets of 15 minutes. All those lead to the same thing. 3/4 of an hour for 9 miles, or 45 minutes. Now, the problem didn't tell us which unit the answer should be in, so either of those are good answers. The time would either be 3/4 of an hour or 45 minutes. Both good answers. So for us, the cyclist will take 45 minutes. To cover 9 miles. And there you have it. We didn't need a formula. We didn't need anything else except recognition that a speed gives us information about distance and time, and then number sense to figure out a good way to figure out how long it would take to travel those 9 miles. Now, there are formulas. So let's real quickly solve this using the formula as well, so you can see that we would have gotten the same answer. Now, you might not remember the speed formula, but there's a neat trick for that too. The unit for speed in the problem above was given to us as 12 miles per hour. Now, if we think about that for a second, if we ignore the number for a second and just look at the unit miles is a distance unit. The per, that slash, is a division, and then hour is a unit for time. And look what we have here. Speed equals distance over time, distance divided by time. So we have the formula without actually memorizing a formula and just using the information given to us because they told us the speed. We were able to get the formula straight from that. Now, in this case, we are solving for time. So we are going to set up a quick triangle. And the way this gets filled in is distance goes on the top and speed and time go on the bottom. The reason that is you can imagine the triangle as 2 division problems and 1 multiplication. So speed times time is the multiplication along the base, and then distance divided by speed will equal time, and distance divided by time will equal speed. So there is still a little bit of memorization here, but if you have your unit for speed distance over time, you can plug that into the triangle pretty easily and get out of the various equations. Let's start with t. T is equal to distance over speed. The distance we are covering is 9 miles. The speed is 12 miles per hour. One thing to be aware of, whenever you plug in your units to a problem like this, it's not in there to make life more complicated, but instead it's in there so that you can double check yourself. If you have units that don't match, you need to ask yourself if that's going to cause a problem or not. We have 2 distance units and they're both in miles, so we don't have a problem. The fact that ours is different is fine. It's a time unit. What you want to be careful about is that we don't have 2 different units for time or 2 different units for distance. That's when you can get in trouble. If one of these had been in kilometers and the other one in miles, we would have had to do something else. If one of them had been in inches and the other one in miles, again, you couldn't just plug them in without accounting for that difference. At any rate, we have 9 over 12, which simplifies to 3 over 4. And then miles divided by miles per hour is just hours. And just remember, units behave the same way other fractions do. This would be miles divided by miles per hour. If you recall, that means this is miles over 1 times hours over miles. Keep, change, flip. And then your miles will simplify, cancel out. And you're left with hours over 1. And that's how we got our unit out of this formula to match that 3/4 of an hour. And then again, we could change 3/4 of an hour to 45 minutes because an hour has 60 minutes and 3/4 of 60 is 45. Sorry. And there you have it. If you would like more ways to solve problems like this or other examples, come and check out coolwithmath.com and follow me here.